Hello everyone. So by request, I'm making this video on distance time graphs and speed time graphs. So first we'll have a look at the theory before doing a past paper question at the end. So in these kinds of graphs, we have time on the x-axis and distance or speed on the y-axis. So if we have a flat horizontal line on a distance time graph, it indicates that the object is at rest, which means it's not moving. This is because, for example, let's set a value. Let's say the object is at a distance of 50 meters away from its origin. So as time progresses, the object remains at 50 meters away from the origin. It's at every single point in time, it's always at 50 meters. So therefore we can see that the object is not moving, it's at rest. In comparison, if we have a flat line on a speed time graph, it indicates that the object is traveling at constant speed. For example, if it's traveling at 5 meters per second, we see that as time progresses, at any point in time, it's always traveling at 5 meters per second. So if we summarize this here, if on a distance time graph the gradient is 0, it means the object is at rest. Whereas a gradient of 0 on a speed time graph indicates that it's traveling at a constant speed. Now let's take a look at what happens if we have a positive gradient on these graphs. So let's say we have this line right here on the distance time graph, and we have this right here on a speed time graph. So on a distance time graph, a positive gradient like this indicates that the object is traveling at constant speed. So if we have a regular gradient here, it indicates that it's traveling at a constant speed. In fact, the speed of the object can be determined by the gradient of this graph. So, for example, if we had at 5 seconds, the object was 10 meters away, and then at 10 seconds, the object was 20 meters away. The speed of the object can be calculated by the gradient of this line. The gradient is equal to rise over run. The reason why the speed can be calculated in this way is because if you cast your mind back to the formula triangle of speed, distance, time, which by the way is in my full formula booklet. If you haven't already taken a look at it, do check it out. It has a lot more formulas. But from the formula triangle, we know that speed is equal to distance over time. And from the gradient of this graph, we see that the rise or the change in y value is equal to the distance traveled within that time, and the change in the x value is the time that is elapsed. And hence we see that the gradient is in fact the speed, since it equals to distance over time. So therefore, for this particular case, it would be change in y value over change in x value. So 10 meters, the change in y is 10 meters because 20 minus 10 is 10. And the change in time is 10 seconds minus 5 seconds, which is 5 seconds. So in this case, it's traveling at 2 meters per second, the object. And in that way, you can use the gradient to calculate the speed. on the other hand, here, when we have speed time graph, and this is positive, let me just finish this up here. Positive gradient is constant speed. And here, when we have a positive gradient, a constant gradient indicates constant acceleration. So if we take the same values from the previous example, and we have at 5 seconds, the object is traveling at 10 meters per second. This time we're working with speed. And then 5 seconds later, it's traveling at 20 meters per second. The gradient m would be equal to the change in y value, which we know is 10 meters per second, divided by the change in time, which is 5 seconds, which gives us 2 meters per second squared. And so we see that the gradient gives us the acceleration, because acceleration is defined as the change in speed divided by the change in time, which here is just the same as the gradient. So that's how we use the gradient to calculate the acceleration. So yeah, that's pretty much all the theory we need to know for the IGCSE maths course. Now let's crack on with this past paper question. So we have a speed time graph here, and a car is accelerating for u seconds until it reaches a speed of 10 meters per second. So remember, the gradient of this graph right here is equal to the acceleration. Hence, why the question tells us that it's accelerating for this part of the graph. It then travels at a constant speed of 10 meters per second. Remember, a flat line indicates a constant speed on a speed time graph for 2u seconds. The distance traveled by the car in the first 3u seconds is 125 meters. So within this time, it has traveled 125 meters. And one more important part of a speed time graph is that the area underneath the curve represents distance traveled. Let me add that up here. Area under a curve gives us distance traveled. So all we have to do is find the area of this part underneath the curve and then set it equal to 125 meters, since that is the distance it has traveled in this time. And then we can use that to solve for u. So there are two ways of doing this. We can either calculate the area of this as a trapezium, and you should know the formula of a trapezium. It's also in my formula booklet if you're not sure about that. Or to simplify things, we can calculate the area of this triangle first, and then the area of this rectangle. So let's do both ways. Let's first calculate the area of this trapezium. So the formula for area of trapezium is height multiplied by a plus b over 2, where a plus b are the two parallel sides. So in this case, they would be these parts of the graph, a, b. And the height is just the height of the trapezium, so that'll be here, height. So we know the height is just 10, because the maximum height of this trapezium is 10 meters per second. So 10, and a would be 3u up here, and we know that this is u here. So therefore a is the distance between u and 3u, which would just be 2u. So a is 2u plus b. B is just the base of this trapezium, which is 3u as its whole. So 2u plus 3u over 2. And then if you simplify this will give you 25u. So the area underneath this curve is 25u, but they've given us that the distance is 125 meters, and we know that the area under speed time graph is equal to distance traveled. Just to be sure that this really is 25u, let's do it with the triangle method. First this triangle, and then the area of this rectangle. So the area of the triangle is equal to base times height over 2. And the base here is just u. And the height, as we've seen before, is 10. So therefore the area of this triangle is base, which is u, multiplied by 10 over 2. And this is equal to 5u. And now the area of the rectangle over here, like we've seen before, this value a here is 2u. So that would be the length of the rectangle, and the width is the height, which is just 10 as we've seen before. So the area of the rectangle is equal to 2u multiplied by the area of the rectangle is length times width, therefore it's 2u multiplied by 10, which is 20u. And as we see, if we add up the area of this triangle and the area of this rectangle, if we add these two together, we get 25u, which is indeed the same value that we've got here with the trapezium formula. Just knowing the formula of the trapezium, it just makes it a lot easier. So now we can set, since the area on the curve is distance traveled and the area is 25u and the distance traveled is 125 meters, we see that 25u is equal to 125. Therefore, if we divide both sides by 25, we see that u is equal to 5. So therefore, the value of u is equal to 5. Now that we know the value of u, it's asking us to find the acceleration in the first u seconds. Or in other words, we can now replace this with 5. In the first 5 seconds. But remember, the gradient of the speed time graph is equal to acceleration. So in order to calculate the acceleration in the first 5 seconds of the graph, all we have to do is find the gradient. And the gradient in this case is the change in y over the change in x. Or in other words, the change in the speed over the change in time, which we've already deduced before is equal to acceleration. So for the first 5 seconds, the change in speed is this part right here, which is 10 meters per second. It's this part, so 10 meters per second. So 10 divided by the change in time. Well, we know that u is 5, so then the change in x value is just 5 as well. So then the gradient of this part of the curve is 10 divided by 5, which is 2. Therefore, the acceleration is equal to 2 meters per second squared. And hence, we can write down here 2. And that would give us the full marks for this past paper question. So yeah, this is what you need to know for IGCSE maths, speed time graphs and distance time graphs. And like I said before, a lot of the formulas from the formula booklet will come in handy into this area. So it's worth checking it out. It's on my main YouTube page. And yeah, I hope this video was helpful. If it was, please like, share, subscribe. And if you have any more problems you'd like me to go through, please let me know by putting them down in the comments below. Thank you.